Here's the experimental setup for experimental determination of the wavelength of the given laser light. And here's the laser source. This is the laser source, very less power laser source, and it's producing red color laser. And here's the double slit plate, and it has 4 different types of slit separation lines. So we're using line number A. It has a slit space, which is small d, right, in our formula. Slit separation or slit space is 0.250 millimeter, and at some distance further away from the space, you will see this screen. As you can see, you will see a clear fringes, right? Those bright dots, bright fringes are because of the constructive interference, and you have dark space, between them due to this destructive interference. That's what you expect. And just by measuring the fringe separation, which is beta, you can find out the wavelength of the laser light easily. And this is the distance between slit to the screen, So I use the tape measure to measure the distance between from slit to the screen, and it's about 140 centimeter. As you can see, it's 140 centimeter is the distance of the screen from the double slit, which is big L in your formula. And again, this is the setup for calculating the wavelength of the given laser light experimentally using a diffraction grating. So again, the same laser light, and here's the diffraction grating plate I put in on a sample holder. And now if you shine a laser light through the diffraction grating, you can clearly see the 3 dots, right? Those are the dots due to the constructive interference, and you can apparently you can see only 3 dots, and how many dots you can see depends on the number of lines fabricated on the given grating element, So then you, just by measuring the distance between one of the dot on the left or right from the center, you can easily find the wavelength of the given light. But here you cannot assume assume a small angle approximation. So sin theta is not equal to tan theta. Be careful when you do calculation. So for the diffraction grating, the big L, the distance between the screen and the given diffraction grating plate is about 46 centimeter, as you can see, right? It's about 46 centimeter, yeah. 46 centimeter. Okay. And here's the distance between one of the dots on the left, and the center dot, center interference fringe. And the distance, when I measure, the distance is about 42 centimeter. Okay, so write that down. The 42 centimeter is the distance of the one of the dot on the left from the central fringe.